Hello guys, welcome back to our channel. The paper we are solving today is IGCSE Chemistry paper 4 and this is the October-November series 2023. Alright, now let's start with the first question. In this question, they have given you our data of electronic configuration of different elements. They're also not telling you what those elements are. So we probably have to figure out those elements based on the configuration and the properties they tell us. Alright, now first, they're asking, tell us which one is a noble gas atom. Now, just think about it. Noble gases are these helium, neon, argon, krypton, and so on. Helium has a configuration 2, 2. After this, all of them have a stable octet, which is 2, 8, then 2, 8, 8. So, you have to figure out the one with 2, 8. So, the answer is B. Now, an atom of an element in group 4. How do we figure this out? See, the elements have same number of valence electrons as the group number. Valence electrons is the same as group number. So what is the group number here? It's not group number 4, it's group number 6. In case I mentioned 4, it's wrong. This is 6. Now, if group number 6 is here, so you have to figure out the one with valence electron 6. What is the answer? Answer is F. Now, an atom with the atomic number 14, so you just need to look at the data and add the number of electrons, you'll get the answer. According to me, D is adding up to be 14, so the answer should be D. Now, in option D, part D, you have to figure out atoms from the same group. Now, just think about it. If the atoms are from the same group, they must have same number of valence electrons, right? So, we have to pick the two with the same number of valence electrons. This is 5 here and this is 5 valence electrons here. So the answer should be A and E. A and E. A has the electronic configuration 2, 5. E has the electronic configuration 2, 8, 5. So they have the same valence electrons. Now, which one is a halogen atom? See, halogens are part of the group 7. So again, as mentioned, they should have 7 valence electrons. Let's pick the one with 7 valence electrons and it is appearing out to be G. So the answer should be G. An atom of an element which is a good conductor of electricity. So now we know that metals are good conductors of electricity and group 1, group 2 elements are also metals. The group 1s will have valence electron 1, group 2 will have valence electron 2. Let's see if we can find something like that. And if you look at C, it is saying 2, 8, 2. Means this is a group 2 metal. In fact, it is magnesium. Magnesium is a group 2 metal only. So the answer should be C. Not for this. The answer for F is C. This is the one we are doing. Now the next part, a stable ion of group 5 element. This is a little bit good question. We can say not difficult. It's conceptual. Stable ion. What does stable ion means? Stable ions means which has octet complete octet, right? Now, when you're talking about group 5, you're talking about that group, nitrogen, phosphorus, this group. Then, in group 5, the valence electrons are 5, but they're not asking about group 5 element. They're asking about stable ion from group 5. So, again, you need to look at something which has a stable configuration. And in the data, the stable configuration only one has, that is B. So, your answer should be B here. I hope you're getting my point. Look at nitrogen. The atomic number is 7. So, the configuration is 2, 5. If they were asking you the atomic configuration of group 5 element, this should have been the answer. But they're not asking you the atom configuration. They're asking you the stable ion. You know that nitrogen forms a negative charge, negative 3. Only then it becomes 2, 8. This is why we are picking the one with 2, 8. That is why the answer is B. I hope it makes sense to you. Now, an atom that forms an ion with negative 2 charge. Now just think about it. Which atom would form negative 2 charge? You have seen it multiple times. Oxygen can form negative 2 charge and the elements in the same group. Oxygen, sulfur, selenium and so on. This is group 6. So the atom must have 6 valence electrons. Which one is it? It's option F. Option F, the part F. So the answer is F. Because if you look at F, it is 2, 8, 6. So that's it. Alright. Now, question number 2. Cobalt and copper are transition elements. Alright. They have given you a table. I'm sure you've done these questions multiple times. You look at the periodic table, find out the atomic number of cobalt, it comes out to be 27. You do the same for copper, it is 29. Now, neutrons, how will you find 59 minus 27? 65 minus 29. In this case, the answer will come out to be 32 and 36 here. They're asking you number of electrons. For number of electrons, you need to look at the form given. In this case, cobalt atom is given. And you know that when atom is there, number of protons are the same as number of electrons. So it is 27 only. Now you look at the form of copper given. Is this an atom? No. This is an ion, and to be specific, this is a cation where deficiency of electrons are there. You can just remember it this way, that if there is positive charge, it means deficiency of electrons. Positive 2 means 2 electrons less than the protons. So 29 protons are there, 27 electrons must be there. Alright, now next part. Table 2.2 shows the relative abundance of the two naturally occurring isotopes. So isotope are given, and their mass number is given, and their percentage is given. This is a very simple maths question. What you can do is you can take out the mass occupied, 70 by 100, that is a percentage of 63 times 63, plus 30 by 100 times 65. This will give you the atomic mass. Now, in case you have learned this using any other formula, I'm sure you must have done it this way then. Your teachers might have taught you just multiply the mass with the relative abundance and add for the other one as well, and then divide by 100. It's ultimately the same. From both methods, you will get the same answer, which is 63.6. So you do not have to worry. You'll ultimately get the same answer only. All right. Now, next question. One physical property of transition elements such as copper and cobalt is that they are hard. Other metals such as lithium are softer. State two other physical properties of copper and cobalt. We know that transition metals have high melting point and they have high density compared to the regular metals. So these are the 2 points. Alright, now let's move on to the next question. Part C. Define the term water of crystallization. Define the term water of crystallization. So you can simply mention that when water molecules are present with salt structure and water molecules are present in hydrated form. Water molecules are present in hydrated form. That's it. Alright. Now, state the color and the formula of hydrated cobalt chloride crystals. Give me 1 minute. Yes, now. State the color and formula of hydrated cobalt chloride crystals. Hydrated cobalt chloride crystals are pink in color. Pink in color, and the formula is COCl2 dot 6H2. Remember, they can also ask for copper sulfate. So copper sulfate crystals are 5H2O, but for cobalt chloride it is 6H2O. Alright. State the color change when few drops of water. So this is just a test for water. When you add water to cobalt chloride, initially it is white in color, but then it turns to blue. And this is not for cobalt chloride, this is for copper sulfate. When you add water to copper sulfate, it turns from white to blue. State how this color change can be reversed. How can you reverse this? Just think about it. When you are adding water to it, it is converting to blue. So when you heat it, then it can be reversed. So you can mention heating here. Alright, now let's move on to the next question. Iron is manufactured in a blast furnace. Three of the starting materials added to the blast furnace are coke, iron core, and limestone. Name the other starting material. Hot air. Hot air is passed through. So the answer should be hot air. Name the main ore of iron which contains Fe2O3. The answer should be hematite. The iron in Fe2O3 is reduced by reaction, alright. We just have to balance this. So you put a 3 here, then another 3 here, then another 2 here. This is balanced. State the change in oxidation number of iron in the reaction in part 2. Now, just think about it. You have to figure out the change. So you have to look at the oxidation state here and look at the oxidation state here. In the product, it's in atomic form, and we know that in atomic form, in elemental form, the oxidation state is 0. Alright. So it's going from something to 0. Now, what is the oxidation state in Fe2O3? This is a very simple to do this. See, there are two iron atoms. So write 2 times X plus 3 times, what is the charge on oxygen? Negative 2 is equals to 0. So 2x is equals to 6, x is equals to plus 3. Alright, if you want to study this topic in detail, I've also put up a video on YouTube on my channel regarding redox. It will help you understand everything in detail. But I think you got this method that total charge is 0. So the sum of charge of iron and oxygen should be equal to 0. This is why we are equating it to 0. Alright, now explain how the change of oxidation number shows that iron has been reduced. See, when increase of oxidation number is there, when oxidation number increases, that is oxidation. When oxidation number decreases, that is reduction. Now you can see oxidation number is going from plus 3 to 0. So that is reduction. So what you need to mention is that there is a decrease in oxidation number. Decrease in oxidation number is reduction. That's it. Now, major impurity in iron ore is silicon 4 oxide. Limestone is added to the blast furnace to remove this impurity. Write two symbol equations to show that silicon 4 oxide is removed. How it is removed? For each equation, state the type. So you have to tell the equation as well as what type of chemical reaction is it. So we remember that the fourth equation is calcium carbonate thermally decomposes to form calcium oxide and CO2. And what is the type of reaction? This is thermal decomposition reaction. Then the last one is where calcium oxide combines with silicon oxide to form CaSiO3, which is your slag. And what is this? This is a acid base reaction. Now you might be thinking, I can't see a base or acid here. Just think about it. It's a metallic oxide. Calcium oxide is a metallic oxide, which is basic in nature. And silicon oxide is a non-metallic oxide, which is acidic in nature. That is why this is an acid-base reaction. Alright, now iron is converted to steel by mixing it with carbon and other elements. We know that stainless steel is made by mixing iron, nickel, chromium, carbon. So state the term given to a substance which is a mixture of metals. This will be an alloy. Name one element other than carbon mixed with iron in the making of stainless steel. So for this you can write anything out of nickel or chromium. It's your choice. Both are correct. Preventing the rusting of steel is important. State the chemical name of rust. The chemical name of rust is hydrated iron 3 oxide. Alright, you need to keep this in mind. Also, we need to tell the oxidation state of iron. The general formula is Fe2O3.XH2O, but you need to mention that the oxidation state is 3. Steel can be coated with zinc to prevent rusting. This provides both a barrier method and sacrificial protection. State the term used for coating steel with zinc. When you coat something with zinc in order to prevent the metal, that is galvanization. So, galvanization. Describe another barrier method for preventing rusting. Now, they're just asking a barrier method, so you can do greasing, you can do painting, or you can just coat with plastic, your choice. Explain how zinc provides sacrificial protection. So they're simply asking you that if this was steel, what you're doing now is you're coating it with zinc. You're putting layers of zinc on top of it. So how does it actually help? See, we are coating zinc onto steel because zinc is more reactive. Zinc is more reactive than iron in the steel, than iron in steel. So it reacts first in comparison to iron. So whatever kind of moisture that will be in contact, oxygen will be in contact. First of all, zinc will react, then your steel and iron will be safe. All right. Now, question number 4. This question is about lead chloride. A student prepares a sample of insoluble lead chloride. So this is the precipitation method, and where they use two different salts in a beaker. Identify two soluble salts suitable for making lead chloride. Now you just have to think, see, lead chloride is your precipitate. Just think about the salts which might give you the chloride part and the lead part. And these two salts that you're using, these should be soluble salts. I hope you remember this. In precipitation, the two salts that we use, they need to be soluble salts. And one tip for all of you, that all nitrates are soluble. All nitrates are soluble. So you can pick lead nitrate. So we got the lead part. Now how do we get the chloride part? Which chloride is soluble? You have to remember the salt solubility rules. Which chloride is soluble? Sodium chloride is soluble. Why? Because this is the easiest one. See, span salts are soluble. Sodium, potassium, ammonium, nitrate, all these salts are soluble. This is why I am going with the safest options. Lead nitrate is soluble because it's a nitrate. Sodium chloride is soluble because it's a sodium salt. Very simple. So your answer should be lead nitrate and sodium chloride. Write the ionic equation for the formation of lead chloride by mixing two aqueous solutions. See, it's a 3 marker, but you need to tell the ionic equation for lead chloride. For this, I'll give you one very simple method. See, lead chloride is your precipitate. So we can mention solid here. Just think about it and think which ions combine to form lead chloride. I will repeat again. Which ions combine to form lead chloride? According to me, lead ion must be there and chloride ion must be there. Make sense? You have lead chloride. I'm asking you which ions are combining to form lead chloride. So that would be Pb2 plus and Cl negative 1. It should be 2 here. You add this, write aqueous here, write aqueous here. This is your ionic equation. You will get 1 mark for writing this, 1 mark for writing this, 1 mark for writing this. 1 mark for the state symbol, sorry. 1 mark for writing the reactants, 1 mark for writing the product, and 1 mark for writing the state symbols. That will be your 3 marks. All right. There are a lot of methods out there to solve these kind of questions, but I'm giving you the simplest one. Just think about it. Lead chloride is made from which ions? It's made from lead ion and chloride ion. Then you do the balancing. You get the answer. All right. Now, next part, list the steps the student should take in preparing a pure sample of lead chloride from the mixture in the beaker. See, pure sample of lead chloride and you're doing precipitation here. Remember, in precipitation, an insoluble salt is formed. At the same time, there is a soluble salt as a product. Soluble salt is also there as a product. That is why we need to first of all filter, then wash with distilled water to get rid of soluble impurities. The soluble salt you have as a product, you do not want soluble salt. You're trying to prepare insoluble salt. So you wash it away with water because it's soluble, it will mix with water. Alright. Then dry the residue. You dry the residue between filter papers. Alright. That's it. Now, next part. The student carries out an electrolysis experiment on molten lead chloride using the apparatus shown. Chlorine gas forms at the anode and escapes from the apparatus. So this is an electrolysis setup. Explain why lead chloride needs to be molten before it will conduct electricity. See, Ionic compounds need to be in molten or aqueous state for them to be able to conduct electricity. The simple reason is that in aqueous or molten state, they have free ions. Ions are free to move. So you can mention mobile ions, or you can mention ions are free to move. Your choice. All right. Write the ionic half equation for the reaction occurring at the anode. Now let's look at the electrolyte. Electrolyte here is lead chloride. It contains Pb2 plus ions and Cl negative ion, right? And since it is molten, H2O is not present. So these are the only ions present. All right. Now they're asking you what happens at the anode. What is anode? Anode is the positive electrode. Anode has a charge of positive. Now just think about it. Positive will attract what charge? Positive or negative? Positive will attract negative. So the equation will be 2Cl negative is equals to Cl2 plus 2 electrons. I hope you remember this. So write the ionic half equation. There it is. This is your ionic half equation. State the test for chlorine gas. It bleaches damp litmus paper. So this is what you can mention, that test is damp litmus paper. And what is the observation? It bleaches it. Turns white. By bleach it means turns white. Alright. State what is observed at the cathode. Now you only had these two ions, Pb2 plus and Cl negative. So cathode is a negative electrode. Negative will attract positive charge, so Pb2 plus will form Pb2 plus 2 electrons giving lead. But now they're asking you the observation. They're not asking you the equation or the product. See, if they're asking you the equation, then you just had to write this. If they were asking you the product, you just had to write lead. But they're not asking any of those. They're asking you the observation. So for this, you need to remember the color of lead, which is shiny gray. You can say shiny gray solid forms. Alright, now next question. Chemical reactions can involve transfer of thermal energy. State the term used for transfer of thermal energy during a reaction. That is the enthalpy change. State what happens, if anything, to the rate of forward reaction if the concentration is increased. Now just think about it. And they are not asking what happens to the equilibrium, they're asking what happens to the rate of forward reaction. So when you increase the concentration, first of all, rate of reaction increases. When you increase the concentration, rate of reaction increases. Why is that? Because there are more particles per unit volume now. More particles of CCl4 per unit volume now. This is what it means by increasing concentration. So if there are more particles per unit volume, then the frequency of collisions between CCl4 and H2O will also increase. Very basic logic. This is what you had to mention. Rate of reaction increases, more particles per unit volume are there, so frequency of collision also increases. State what happens to the position of equilibrium, if anything, when the pressure is increased. See, when you increase the pressure, equilibrium favors the side with less gaseous molecules. When pressure is increased, it favors the side with less gaseous molecules. So now let's check. There is one molecule here, two molecules here, in total three. One molecule here, four molecule here, in total five. So when you increase the pressure, it will favor the side with less gaseous molecules, and according to this reaction, that side is the reactant side or the backward side, or you can mention left. So your answer should be that the equilibrium moves to left, that is the reactant side. Why? Because it favors, since you have increased the pressure, so it favors the side with less gaseous molecules, which is towards the left. Next question. Incomplete reaction pathway diagram is there. On figure, you have to insert the formula of the reactants and products. So, see, the reactant are these. So, you just mention CCl4 gas plus 2H2O gas. Make sure to mention the state symbols as well. Product as well, CO2 gas plus 4HCl gas. Draw an arrow labeled activation energy to show the activation energy. See, this is an exothermic reaction. There, the activation energy required is quite less. So, this is your activation energy. Draw an arrow labeled delta H to show the transfer of energy in the reaction. So, that will be decreasing like this, delta H, which is negative because it's an exothermic reaction. Define the term activation energy. It is the minimum amount of energy required for reactant molecules to start colliding. Reactant molecules to start colliding. Or you can mention, the better definition will be that the minimum amount of energy that colliding particles must have to react. Very simple. State one way by which activation energy can be changed, that is by adding a catalyst. Catalyst decreases the activation energy. Now, next question. This is a calculation question. State the energy needed to break the bond. See, energy needed to break the bonds means they're asking you the net energy for the reactants. Net energy for the reactants. I'll show you how to calculate this. See, first of all, you count all the bonds. One CCl bond, another CCl bond, another CCl bond, another CCl bond. So we have 4 CCl bonds. Then one OH bond, another OH bond, another OH bond, another OH bond. So you have 4 OH bond. This is for your reactants. Now, when you do 4 times, what is the CCl energy? 340. 4 times, what is the OH energy? 460. When you do this, your answer will come out to be 3200 kilojoules per mole. That should be the answer here. Alright. Now, calculate the energy released when bonds in carbon dioxide formed. When bonds in carbon dioxide are formed. So you just look at carbon dioxide, there is one C double bond O, another C double bond O. There are 2 C double bond O. So that will be 2 times C double bond O, which is 2 times 805. The answer is 1610 kilojoules. Unit is already given. Calculate the HCl bond energy. So it's a good question. They're not directly asking you the enthalpy change. They must have given you the enthalpy change and they're asking you for one of the bonds. Now see, just think about it. What we usually do is, we do that reactants energy minus product energy is equals to the enthalpy change. Now in general questions, you figure out the reactant energy, you figure out the product energy, subtract it, you will get the enthalpy change. But in this question, they have given you the enthalpy change. They're asking you energy for one of the products, that is HCl. One of the products. Now this is simple maths only. I'll show how to do this. See, you figured out reactants energy. How much was it? Reactants energy was 3200. In the same way, let's try to figure out products energy. I know that we do not know the value of one of the products. Fine, let's write it in form of equation. Alright. You have 2 carbon oxygen bonds in the product and 4 HCl bonds. Is that right? 4 HCl bonds, right? So I will write 2 carbon double bonds, oxygen, and 4 HCl bonds. Right. Let's do reactant minus product. That will be equal to enthalpy change. And enthalpy change is given negative 130. So reactant minus product is equals to negative 130. Now just think about it. 3200 minus energy of the products, and energy of products is 2 times C double bond O Let's write it properly. 2 times C double bond O, and it is 4 times HCl, right? 4 times hydrogen chlorine bond, and that is equals to how much? Negative 130. Now just think about it. It's basic maths. You know that 3200 is there, minus 2 times CO bond energy is this 1610. So minus 1610 minus 4 times HCl bond is equals to negative 130. So there is only one variable now. I think you can solve it, right? So the answer will come out to be 430 kilojoules per mole when you solve it completely. I've given you the equation, just put it in the calculator, rearrange, and you'll get the answer. Question number 6, last question of this paper. A homologous series is a family of organic compounds whose members have similar chemical properties. Give two other characteristics that are same for homologous series. See, chemical properties they have already mentioned. We know that functional group is the same. So you can mention they have same functional group and same general formula. Do not write in short form, write in full form. Alright. In terms of structure, state how one member of homologous series differs from the next. See, let's take example of ethane and propane. Ethane is C2H6, propane is C3H8. What is the difference? There is a difference of carbon and two hydrogen atoms, right? Even if you look at butane, that will be C4H10. Again, what is the difference? One carbon and two hydrogen atoms. So they differ by CH2. This is what you have to mention. Alright. Next question. A, B and C are organic compounds. A has the molecular formula this C12H24. So this is an alkene. How do I know this? In alkenes, the hydrogen atoms are exactly double of the carbon. B has the same name tetradecane. So see, this is a tetradecane, means alkane. C has 3 carbon atoms and is in the homologous series with the general formula CnH2n plus 1 COOH. Alright, name the homologous series each compound belongs to. A is alkene, just like we discussed. B is an alkane, just like we discussed. And C, this is a general formula of carboxylic acid. So your answer should be carboxylic acid. Name C and draw its displayed formula. Now, a lot of students end up making mistakes in this. Just think about it. They're saying that C as a molecule has 3 carbon atoms. C as a molecule has 3 carbon atoms and it's a carboxylic acid. So, what is a 3 carbon atom carboxylic acid? It is propanoic acid. Now, when you draw the structure, draw 3 carbon atoms, put one double bond O, then H, then satisfy the other valencies. Now, I'll tell you the mistake a lot of students make. They remember the general formula CnH2n plus 1 COOH, and it is also given. Now, what they will do is that, oh, question it is mentioned, question is saying there are 3 carbon atoms. So, in place of N, they will end up substituting 3. So, this will be 7 COOH, right? Now, if you count in total, this is 4 carbon atoms. The carboxylic acid carbon also counts. So they end up making mistakes here. They will directly use the general formula and they will say now number of carbon atoms 3 is given. I will put 3, but ultimately it comes out to be a total of 4 carbon atoms. So avoid doing this. Simply draw 3 carbons, put double bond OH, then satisfy the valencies. This is your answer. Now, D part. Amino acids are a homologous series where each member has general structure. Alright, this is a general structure. Correct. An amino acid has a relative molecular mass of 103. Relative molecular mass of 103. Deduce the formula of R side chain. Now, what they're telling you is that this is an amino acid and the total mass is 103. You have to tell me the mass of this R. Now just think about it. It's very basic maths. From periodic table, you can check the atomic mass of nitrogen, hydrogen, 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 carbon, carbon, oxygen, oxygen, hydrogen. So what's remaining? Only R is remaining. You subtract it, you will get the answer. Right? How many carbon atoms are there? 2 carbon atoms. Plus how many oxygen atoms are there? 2 times oxygen. How many nitrogen? Only one nitrogen. And how many hydrogen? One, two, three, four. Four hydrogen. Plus the mass of R is equal to 103. What is difficult in this? This is 12 plus 24 plus nitrogen's mass is 14 plus hydrogen is 4 plus R is equals to 103. When you solve this, your answer will come out to be 29. That is the mass. State the name given to the natural polyamides formed from amino acids. Natural polyamides formed from amino acids. Now, in our syllabus, there are two polyamides. One is nylon, but nylon is not made from amino acids. Nylon is made from dicarboxylic and diamine. So, which one they are talking about? What forms amino acid? Proteins are formed from amino acids. So, the answer is proteins. Alright, this is it, guys. We are done with the paper. In case of any doubts, feel free to let me know in the comment section.